everyone. We're going to take a look at our next lesson in this video. And as you know, we've been working our way through Unit 3 for acute and obtuse triangle trigonometry. In this lesson, I want to take a look at the last section in the first chapter, chapter 3, where we're putting together the law of sines, the law of cosines, and regular sine, cosine, and tangent to help us tackle various problems involving acute triangles. And so the aim is really just to be able to put into practice the various tools that we've now gathered together. A couple of hints to help you out as you try to tackle these questions. Remember that your diagram is a really essential part of what you do. Please use a ruler. Please draw it carefully. Please take your time with it. Try to make sure that you are describing the information that's in the question. The better your diagram, the easier your work will be. And also, once you've got that diagram in place, that will be your chance after you've got it to determine what your strategy is. Are you going to use the law of sines, law of cosines, regular trigonometry? You'll be able to tell from that point on. So now, before we get started, let's just go through a bit of a practice run and decide, what strategies would we use. Keep in mind, we've got regular trigonometry we could use, the law of sines, or the law of cosines. So if you were given the following, where you have two angles and one side, keep in mind, of course, that you could find the third angle very, very easily. Then it means that the law of sines is a natural one for you to use because you have a side and its opposite angle. The next one, if I gave you two sides and an angle in the center. First, most people do try to use the law of sines first once they realize they can't use regular trigonometry and realize, okay, there's no way we can because we don't have the opposite side of this angle that we're given. So we will use the cosine law. If you're given three sides, once again, we don't have that combination of angle and side, and so we will use the cosine law. For this one, as we set it up, you see right away, okay, I do have the side and its opposite angle, and so I should be good to use the law of sines. So let's take a look at a couple of word problems, and I would encourage you to, as I come to them, to stop the video, read it yourself, and try to jump in and see what you can do, especially about drawing diagrams or getting started on the strategy. What we're looking at here is a question surrounding the Dry Island Buffalo Jump in Alberta. This was a historic place where the buffalo were forced, kind of herded off over the cliff and fell to meet their fate, and that's how they were hunted at a certain period of time. So the example we have is that Brendan and Diana plan to climb the cliff at Dry Island Buffalo Jump in Alberta, and they want to know the height. So they want to know what is the height from C to A in this picture. Now they're using a clinometer right now to make some measurements on the ground. They've got two spots where they're sighting it. So they're looking across to the spot at the bottom of the cliff. And they're using a line of sight, and it tells them that this is a 50-degree angle, whereas the one over here at B is a 60-degree angle. So they form this triangle, knowing that the distance between those two spots of sighting are 60 meters. And then from the same spot, they're looking up to the top of the cliff, and they realize that the angle is 76. So if you could imagine, this is like the two triangles are folded together almost, and that this one is flat and this one is straight up and down. So we're going to try and see if we can figure out how high it is. So first we're going to focus on this bottom triangle that's sitting there and realize we can find the third angle because this one's 50 and 60. That allows us to use the law of sines. So 60 over the sine of 70 is the same thing as, and we're going to go for this side, so x or CB, or you could call it D even, over the sine of 50. Moving things around a little bit, you'll have 60 times the sine of 50, and you'll divide it by the sine of 70. Gives you an answer on this bottom part of 48.912. Now, if you take that, then I'll go back just for a second so you can see. Since you know this bottom one is 48, you're going to use tan, because tan is opposite over adjacent. So you're going to use the x over your 48.912. Tan is 76. And that gives you the approximate height of the cliff to be about 196. The next question is going to be surrounding this totem pole, which is a very beautiful, tall totem pole. In fact, it's the world's tallest freestanding totem pole located in Beacon Hill Park in Victoria, British Columbia, a beautiful park in a beautiful city. While visiting the park, Manuel wanted to determine the height of the totem pole, so he drew a few things. And here he's added some information in this drawing. First of all, the totem pole is at the bottom of an incline. And Manuel was able to give a reading and estimate that the incline of this hill is about 5 degrees. He also backed off. He could see that the shadow for the totem pole was 42 meters long. And he looked up and was able to measure the angle of elevation to the sun and realized it was 40 degrees. So, what we want to know is what is the height of this totem pole? Now, if you look at your totem pole, realize that the angle of this triangle right here, this one, and that's from C, D to B, this angle would be 85 because this little part is just 5. This is 42. And this guy is also going to be 40 in the corner. Knowing that this is 40 and this was 85, we should be able to find our third angle. So sure enough, we've got 45. Oh, why did I say 45? That looks like an error right here. Ooh, it is. That looks like an error for sure. Oh, sorry. No. Let's go back and be sure about what we're doing. Okay. If I go back, oh, it's a good thing I caught that. If I go back and take a look at this little skinny triangle down here, I know that this is 40 and this is 5. That means that this angle right here in the corner at D, this obtuse angle, is 135. And if it's 135, then that means that this guy would be 45. Ooh, good. So now we have our triangle, and we can get our third angle up top, and we can use the law of sines because we know that x over the sine of 45 is equal to 42 over the sine of 50. We do our magic and come up with a height of about 39 meters, which is incredibly tall for a totem pole. The last one we're going to do is a question about some security lights like these ones that are mounted, excuse me, on opposite walls of a museum. And what we're doing is we're looking at these lights are going to be angling down to shine on top of this display case. All right, so one's coming down and shining right in the middle, the other one's coming down and shining right in the middle. And let's take a look. 2 security cameras in the museum must be adjusted to monitor a new display of fossils. The cameras are mounted 6 meters above the floor, directly across from each other on opposite walls. The walls are 12 meters apart. The fossils are displayed in cases made of wood and glass. The top of the display is 1.5 meters above the floor. The distance from the camera on the left, I guess it's really the security cameras, to the top of the display, and what they mean is this distance from here to here, as a crow flies, so to speak, is 4.8. Both cameras have to be aimed at the center. So now we need a diagram. Here's my display case. Here's my walls of 6 where my security cameras are located. I have them going downwards. This distance from here to here is 4.8. Since they're 6 high, I know that this part of the triangle would be 4.5. So I believe what I worked on first was to try and find angle theta. And I know that sine is opposite over hypotenuse, so that 4.5 over 4.8 gave me an angle of 69.6. Then, once I had this angle, I was able to use the law of cosines. So let's go back. I'm going to use this angle, and then I would have 4.8 and 12. So I'm going to use this side squared, which is x. And in my diagram, it's x anyway. X squared is equal to this one squared plus this one squared minus 2 times this, cosine of the angle, which we found to be 69.6, gives me a reading of 11.3. And once I know that, then once I know this guy, I can do the sine of alpha equals 4.5. That's the opposite. Over the hypotenuse, which is this guy. And I just found that out to be 11.3. And it gives me an angle of 23.5. Okay, I believe that's it. There you have it, some examples of questions. It's very important that you take some time and go through each one of the questions that I've suggested in your homework. It's really this type of work is kind of tedious, but it really demands that you practice things and give it a try. Take a look at what other people have done in order to learn from it. So good luck with your work and make sure you let me know if you have any questions.